Alright, so let's dive into the incredible world of electric circuits. By the end of this lesson, you'll have a deep understanding of the relationship between voltage, resistance, and current, how they shape our modern world, and how to apply these concepts to solve real-world problems. What is voltage? Voltage, also known as electric potential difference, is what drives the movement of charges in a circuit. Think of it like the pressure in a water pipe pushing water forward. Without voltage, there's no force to move the electrons, and the circuit won't work. Voltage as potential energy. Imagine a hill with a ball at the top. The higher the hill, the more potential energy the ball has. Voltage works in a similar way. It represents the electric potential energy per unit charge. The greater the voltage, the more energy each charge carries as it moves through the circuit. Equation for voltage. Voltage equals work done divided by charge. Voltage is measured in volts, work is in joules, and charge is in coulombs. Example, problem 1. If 12 joules of energy move 2 coulombs of charge through a circuit, what's the voltage? Using the formula, voltage equals work divided by charge. Substituting the values, 12 joules divided by 2 coulombs equals 6 volts, so the voltage is 6 volts. Real-world connection. Everyday examples of voltage include batteries in your phone or car. A standard AA battery provides 1.5 volts, while a car battery delivers 12 volts to power the ignition system. What is resistance? Resistance is the opposition to the flow of electric current. It determines how easily charges can move through a material. Conductors like copper have low resistance, allowing current to flow freely, while insulators like rubber have high resistance, blocking most current. To calculate resistance, use the formula. Resistance equals voltage divided by current. Resistance is measured in ohms, where 1 ohm equals 1 volt per ampere. Example, problem 2. A circuit has a voltage of 12 volts and a current of 4 amperes. What's the resistance? Using the formula, resistance equals voltage divided by current. Substituting the values, 12 volts divided by 4 amperes equals 3 ohms. The resistance is 3 ohms. Factors affecting resistance. Resistance depends on material. Metals have low resistivity, while rubber and glass have high resistivity. Length. Longer wires have higher resistance because electrons encounter more collisions. Cross-sectional area. Thicker wires have lower resistance, allowing more electrons to flow. Temperature. As temperature increases, resistance typically increases in conductors. Resistivity formula. The relationship is given by the formula. Resistance equals resistivity times length divided by cross-sectional area. Example, problem 3. A copper wire is 5 meters long with a cross-sectional area of 0.01 square meters. If the resistivity of copper is 1.7 times 10 to the negative 8 ohm meters, what's the resistance? Using the formula, resistance equals resistivity times length divided by area. Substituting the values, 1.7 times 10 to the negative 8 times 5 divided by 0.01 equals 8.5 times 10 to the negative 7 ohms. The resistance is extremely low, as expected for copper. What is current? Current is the rate of flow of electric charge. It's measured in amperes, where 1 ampere equals 1 coulomb of charge passing a point per second. Current formula. Current equals charge divided by time. Example, problem 4. If 15 coulombs of charge pass through a wire in 3 seconds, what's the current? Using the formula, current equals charge divided by time, substituting the values. 15 coulombs divided by 3 seconds equals 5 amperes. The current is 5 amperes. Voltage, current, and resistance together. Voltage, current, and resistance are interconnected through Ohm's law. Voltage equals current times resistance. This means you can predict one quantity if you know the other two. Example, problem 5. A 9-volt battery is connected to a resistor with a resistance of 3 ohms. What's the current? Using Ohm's law, current equals voltage divided by resistance. Substituting the values. 9 volts divided by 3 ohms equals 3 amperes. The current is 3 amperes. Understanding voltage and resistance is key to designing efficient circuits. For example, in your home, low-resistance copper wires minimize energy loss. In electronics, resistors control the current to protect components. In cars, voltage from the battery powers the ignition and lights. Practice problem 6. A circuit with a 12-volt battery includes a 2 ohm resistor and a 4 ohm resistor in series. What's the total resistance and current? Add the resistances in series. Total resistance equals 2 ohms plus 4 ohms, which equals 6 ohms. Using Ohm's law, current equals voltage divided by resistance. Substituting the values, 12 volts divided by 6 ohms equals 2 amperes. The current is 2 amperes. And that's a wrap on voltage, resistance, and electric circuits. You've explored the fundamentals, solved problems, and connected these concepts to real-life applications. For more science deep dives and practice, head to kotc.me. See you next time.